Here in Washington, we have our own volcano threat in the Cascade Mountains, which on average erupts once or twice every century.
More numbers. 24 park rangers assisted in the mission on the mountain. It happened on the Liberty Ridge roof.
Mount Rainier, the towering sentinel of the Pacific Northwest, has long stood as both a majestic symbol of natural beauty and a looming reminder of Earth's explosive power. Rising over 14,400 feet into the sky, its snow-covered slopes often project serenity to the millions who live in its shadow. But recently, the mountain has begun to stir in ways that have shaken the scientific community. Geologists have just issued a red alert, indicating that Mount Rainier may be on the brink of a significant eruption, a seismic event that could disrupt lives, infrastructure, and ecosystems across the region. Before we start, smash the like and subscribe buttons for more updates. The alarm did not come suddenly. Over the past few weeks, Mount Rainier has exhibited a steady uptick in seismic activity, with swarms of small earthquakes occurring beneath the surface. These tremors have been shallow and localized, hinting at magma movement beneath the mountain. Combined with increased gas emissions and unusual geothermal readings, the data paints a concerning picture. Crater temperatures have risen more than expected for this time of year, and new fumaroles have opened up near the summit, releasing plumes of steam into the atmosphere. Satellite imagery has revealed slight but measurable deformation of the surface, suggesting pressure is building below. Red alerts are rare in the world of volcanology and are reserved for situations when an eruption is imminent or already underway. This isn't speculation or early-stage warning. It is the highest level of concern, signaling that a full-blown volcanic event could occur within days or even hours. Mount Rainier's last significant eruption occurred around 1,000 years ago, but its potential for destruction has never been in doubt. Designated one of the most dangerous volcanoes in North America, its proximity to major population centers such as Seattle and Tacoma only intensifies the stakes. One of the most daunting threats associated with Mount Rainier is not just its lava or ash emissions, but its capacity to unleash colossal lahars, volcanic mud flows capable of racing down its slopes at tremendous speed. These lahars can form when hot volcanic material melts the vast glaciers that drape the mountain. Given Rainier's immense ice coverage, the potential for devastating mud flows is greater than that of almost any other volcano on the continent. Once formed, these lahars follow river valleys, potentially wiping out everything in their paths, including homes, bridges, roads, and entire communities. Communities in the Puyallup and Nisqually River valleys are particularly vulnerable. These areas, home to tens of thousands of residents, sit directly in the path of known lahar routes. Emergency management agencies have long prepared for such a possibility, with designated evacuation routes and warning systems in place. But preparation on paper can only do so much when reality begins to take hold. The red alert has turned theoretical scenarios into a pressing reality, and the race against time has begun for those in the danger zone. In the midst of this, geologists have been working around the clock to monitor every shift and change in Rainier's behavior. High-resolution seismographs have been picking up harmonic tremor patterns, rhythmic earthquakes typically associated with the movement of magma through underground conduits. At the same time, gas spectrometers have detected spikes in sulfur dioxide and carbon dioxide levels. These changes in volcanic gases serve as chemical signatures of magma nearing the surface. Combined with visual observations from flyovers and satellite imaging, the evidence points to a volcano primed for eruption. The implications of an eruption at Mount Rainier are staggering. Ash plumes, depending on wind direction, could blanket large areas of Washington and even spread into neighboring states, affecting air travel, respiratory health, and agriculture. Volcanic ash is not just a nuisance. It is abrasive, corrosive, and can severely damage engines, electronics, and infrastructure. A significant ashfall could shut down highways, disrupt power grids, and contaminate water supplies, turning daily life into a logistical nightmare for hundreds of thousands. But it is the lahars that remain the most chilling prospect. Historical records and geologic studies have revealed that past eruptions sent massive mud flows roaring through the valleys at speeds exceeding 60 miles per hour. These flows do not simply flood an area, they obliterate it. Reinforced concrete structures can be buried, and landscapes permanently altered. The town of Ording, situated along a known lahar path, has been identified as being at extreme risk, and local schools and emergency centers have already activated protocols to prepare for a possible mass evacuation. Beyond the immediate human risk, the ecological impact of a Rainier eruption could be profound. The mountain is part of the Cascade Range, a biologically diverse region home to countless species of flora and fauna. A major eruption could alter habitats, wipe out forests, and disrupt waterways. Salmon-bearing rivers, already under pressure from climate change and human activity, could be choked with volcanic debris. Wildlife corridors could be severed, and air quality could deteriorate for weeks or even months. Rainier's ecosystem, delicately balanced over millennia, could be thrown into chaos within hours. The red alert has also triggered heightened coordination between state and federal agencies. The United States Geological Survey USGS, in collaboration with the Pacific Northwest Seismic Network PNSN, has increased the number of field teams and deployed additional monitoring instruments around the volcano. Emergency services have been placed on high readiness, and the Federal Emergency Management Agency FEMA has begun staging resources to support potential disaster response. Local authorities have opened shelters and activated communication systems to inform and guide the public. While technology has advanced significantly since the last time Mount Rainier stirred in earnest, no system can predict the exact moment of eruption with complete accuracy. Scientists are relying on patterns, probabilities, and real-time data to estimate when and how the event might unfold. They must weigh the urgency of issuing warnings against the risk of false alarms that could cause panic or lead to evacuation fatigue. With the red alert in place, however, there is little room for ambiguity. The situation is dangerous, and the time to act is now. In the broader context, Mount Rainier's awakening is a stark reminder of the volatile nature of the Pacific Ring of Fire, a zone of frequent earthquakes and volcanic eruptions that encircles the Pacific Ocean. The Cascade Range, of which Rainier is a part, includes other potentially explosive volcanoes like Mount St. Helens, Mount Hood, and Mount Baker. Each of these has erupted in the past century, but Rainier's unique combination of ice, height, and proximity to people makes it uniquely menacing. The psychological effect of the alert is already being felt. Schools are practicing evacuation drills, families are packing emergency kits, and local businesses are bracing for disruption. The atmosphere is tense, suspended in a moment of uncertainty. Unlike hurricanes or wildfires, volcanic eruptions are harder to visualize until they happen, and their unpredictability breeds anxiety. For many residents, the view of Mount Rainier has changed overnight, from a source of pride and inspiration to a potential engine of destruction. Media coverage has ramped up with live updates, expert panels, and constant feeds from monitoring stations. The balance between information and sensationalism is delicate, and officials have urged the public to rely on verified sources and avoid spreading rumors. Social media, though useful for rapid communication, has also become a source of fear-mongering and misinformation. The importance of clear, factual updates has never been more critical. Scientists have emphasized that while eruptions cannot be stopped, their consequences can be mitigated through preparation, awareness, and community resilience. Town halls have been held virtually and in person to educate residents about lahar sirens, evacuation protocols, and the importance of staying informed. Public transportation networks have been placed on standby, ready to facilitate mass evacuations if necessary. Hospitals have reviewed disaster plans and supply chains are being fortified against possible disruptions. For indigenous communities, Mount Rainier, known to some as Tahoma, holds spiritual significance. The mountain is seen not just as a geological feature, but as a living entity with deep ancestral meaning. As geologists focus on scientific data, many native voices have expressed reverence and concern, calling for a holistic approach that respects both the natural and cultural importance of the mountain. The red alert in this context is not just a scientific classification, but a signal of profound upheaval, both physical and spiritual. There is also a broader economic concern. The Pacific Northwest is a hub of commerce, technology, and agriculture. Any significant disruption to transportation corridors such as Interstate 5 or to air travel across SeaTac International Airport could have ripple effects far beyond the immediate region. Local industries, from dairy farms in Pierce County to tech firms in downtown Seattle, are drawing up contingency plans. Insurance firms are already fielding inquiries, and economists are beginning to model potential scenarios for loss and recovery. Meanwhile, scientists are paying close attention to the unique geochemistry of Rainier's magma. Unlike the basaltic flows seen in places like Hawaii, Rainier's magma is more viscous and silica-rich, which means it traps more gas and builds more pressure before eruption. This increases the likelihood of explosive activity, which can propel ash and pyroclastic material high into the stratosphere. The concern is not just local damage, but the possibility of atmospheric effects that could impact regional climates, especially if the eruption proves prolonged or is followed by additional venting. Global interest in Rainier's status is growing. International volcanology groups have started sharing data and analyses, recognizing that the behavior of one volcano can offer insights into others. Lessons learned from Mount Rainier's eruption, should it occur, will shape future response plans, enhance monitoring techniques, and add to the growing field of predictive volcanology. In a world where natural disasters are becoming more frequent and intense, every eruption becomes both a tragedy and a teaching moment. As the situation develops, there's a sense of suspended breath throughout Washington and beyond. Mount Rainier's looming presence has always demanded respect, but the red alert has brought its power into sharp focus. The waiting game now begins, one where each rumble, gas plume, or temperature spike could be the final indicator before the mountain unleashes its fury. Emergency teams are standing by, eyes glued to instruments and screens, while residents look toward the peak with equal parts fear and fascination. The mountain has not yet erupted, but its message is clear. Something is coming. How soon, how strong, and how far-reaching it will be remains uncertain. What is certain is that Mount Rainier has stirred, and when such a giant stirs, the world must listen. As the red alert persists, the countdown to a potential eruption continues, and attention is now turning to the layers of complex systems and interdependencies that would be immediately stressed or compromised if Mount Rainier erupts. The effects of such an event wouldn't be isolated to the immediate vicinity. They would cascade outward, influencing transportation, economy, communications, and public health infrastructure in deeply interconnected ways. At the center of emergency response is the logistics network that keeps the region functioning. This includes roads, bridges, railways, and air routes, all of which are under threat from both the direct forces of an eruption and the secondary hazards it triggers. Key highways such as State Route 410 and State Route 167 are not only transportation arteries for daily commuters, but also lifelines for emergency responders and evacuees. If lahars or landslides sever these connections, entire communities could be stranded, complicating rescue and relief operations. Rail lines that carry both freight and passengers also wind through valleys potentially vulnerable to mudflows. A sudden disruption to rail transport would slow delivery of essential supplies like food, medical equipment, and fuel. Businesses relying on just-in-time delivery models, especially in urban centers, would feel the strain almost instantly. Moreover, rerouting supplies through alternative corridors would be slow and expensive, further compounding economic losses. Mount Rainier's impact on airspace could be just as profound. Volcanic ash presents a severe hazard to aviation, capable of shutting down engines mid-flight and reducing visibility to dangerous levels. Even a moderate ash plume could cause partial closures of SeaTac International Airport, a critical hub for both domestic and international travel. The Pacific Northwest is a key player in global logistics, especially in technology exports and imports via air cargo. Any prolonged disruption here would reverberate through global supply chains. Beyond infrastructure, the eruption would exert tremendous pressure on the public health system. Hospitals in the region, including major centers in Seattle, Tacoma, and Olympia, have limited surge capacity. A mass casualty incident combined with widespread evacuation could quickly overwhelm medical facilities. Additionally, volcanic ash poses respiratory dangers, particularly for vulnerable populations such as children, the elderly, and individuals with pre-existing conditions like asthma or COPD. Inhalation of fine ash particles can cause bronchial inflammation, conjunctivitis, and skin irritation. Mental health is another critical component that would come under strain. The prolonged uncertainty and fear triggered by the red alert can lead to heightened anxiety, depression, and PTSD symptoms, especially among children and those with previous trauma from disasters. Displacement itself is disorienting, often separating families, uprooting routines, and introducing financial instability. Community health organizations would need to mobilize not just for physical ailments, but for psychological support at a scale that exceeds normal operational thresholds. Communication will play a decisive role in shaping outcomes. During natural disasters, the accuracy, clarity, and timeliness of information can determine survival. Right now, state agencies and scientific organizations are coordinating to maintain a unified message about Mount Rainier's activity. But should the volcano erupt, the strain on digital networks, cellular towers, and broadcasting channels could compromise the delivery of vital alerts and instructions. In rural or mountainous areas near Rainier, cellular service is already patchy. A loss of connectivity would further isolate vulnerable communities, making it harder to reach them with warnings or to confirm their safety. Emergency communications units, including mobile satellite systems, would need to be deployed quickly to bridge gaps and facilitate coordination between response teams. Meanwhile, social media, while valuable for rapid dissemination, could become a double-edged sword, amplifying rumors or misinformation unless vigilantly monitored. Local governments already preparing for a worst-case scenario are focusing on shelter logistics and resource allocation. Establishing safe zones for evacuees is one of the most urgent tasks, particularly because of the region's varied terrain and climate. Depending on wind direction and ash dispersion, some designated shelter areas may become compromised. Additionally, maintaining sanitation, potable water, and food supplies at these locations is essential, especially if displacement lasts for weeks. Animal and livestock safety is another dimension that demands immediate attention. Farms situated along the flanks of Rainier and within lahar-prone valleys may have limited time to evacuate animals, many of which represent both economic value and food supply. Coordinated efforts between agricultural agencies and humane organizations are now underway to identify temporary shelters and transport options. Abandoning livestock would not only cause ethical concerns, but also introduce issues related to disease, decay, and food contamination. As the volcano continues to show signs of potential eruption, scientific teams are also closely monitoring interactions between hydrothermal systems and magmatic intrusion. Mount Rainier's vast glacier coverage makes it especially susceptible to rapid melting and steam explosions, a phenomenon known as phreatomagmatic activity. These explosions can occur without warning and are especially hazardous, ejecting rock fragments, boiling water, and ash in a violent burst. If such an event were to precede a full eruption, it could serve as both a warning and a catalyst, altering the course of magma movement or breaching surface layers. Longer-term environmental consequences are also a growing concern. The hydrology of the region is intimately tied to Rainier's glaciers, which feed rivers critical to local agriculture, energy production, and ecosystem sustainability. An eruption could dramatically reshape these water systems, causing flooding, rerouting river channels, and degrading water quality. Sediment-laden lahars can fill riverbeds and reservoirs, reducing water storage capacity and increasing flood risks during seasonal rains. Glacial recession following an eruption would also contribute to changing microclimates in the region. Some watersheds could dry out, while others may experience increased runoff. These shifts affect not just human utility, but biodiversity across elevation bands. Alpine meadows, old-growth forests, and wetlands, all sensitive to slight changes in temperature and moisture, could undergo rapid transformation. These ecosystems have evolved over centuries under specific conditions. A volcanic eruption could alter that balance in a matter of hours. Simultaneously, there's mounting concern over how the region's energy grid would cope. Much of Washington's electricity comes from hydroelectric dams and a network of transmission lines that crisscross the Cascade Range. A significant ashfall could damage substations, degrade insulators, and even short-circuit transformers. Volcanic ash is electrically conductive when wet, increasing the likelihood of widespread blackouts if rainfall follows ash dispersion. Emergency backup systems would need to operate on diesel or gas, which brings its own challenges in terms of storage, transport, and duration. From a geopolitical standpoint, Mount Rainier's potential eruption may also test the coordination between federal, state, and tribal authorities. Jurisdiction over the land surrounding Rainier is divided among multiple entities, including the National Park Service, state governments, tribal lands, and private properties. Effective response requires not just logistical alignment, but also legal clarity. Questions of land access, responsibility for evacuations, and rights to resources must be resolved swiftly to avoid bureaucratic deadlock during critical moments. Internationally, volcanologists are also eyeing Rainier as a case study in monitoring large glaciated stratovolcanoes. Lessons learned here could refine hazard models for similar peaks in countries like Chile, Japan, and Indonesia. Data sharing agreements and academic collaborations are being activated to ensure that as Rainier evolves, so too does the global scientific community's understanding of explosive, ice-covered volcanoes. There is also a cultural reckoning happening as communities confront the volatility of their environment. For decades, development has expanded steadily into lahar zones and floodplains, driven by population growth and economic opportunity. Now, with the threat becoming real, there is growing debate about land use, zoning laws, and long-term habitation in these high-risk areas. Some are calling for a moratorium on further development in known hazard zones, while others emphasize retrofitting infrastructure to withstand potential disasters rather than abandoning the land altogether. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Mount Rainier's eruption risk? Will it erupt soon? We want to hear from you. Thank you for watching and see you next time.